Okay, so the previous video was going over the closed loop with the Tweedo Suite addressing, but you'll see that it's essentially the same here with the forward reverse on the Allen Bradley. So we said that once we had done that base setup, then we'd be able to open up that program. So there's my basic setup right here. So the beauty of this is that my I/O is already done, right? So if I go in here into my I/O configuration, it's already done. So you can open up that base setup there. Looks like I made a mistake and I've got my previous forward reverse open loop in there. So let me just get rid of those guys. Okay, and I will resave this as my basic setup. And then I won't have a program dropped in there. Okay, so now we're going to do the closed loop for the forward reverse. So let's drop in a rung. And remember that each of these guys for the forward and the reverse are going to be carbon copies of each other. So once we do one of them for the forward, we'll wait for a little bit to put in our addressing, and then we can copy and paste for the reverse. So for this guy, we're going to have, let's see, our stop push button is an XIC, which we've already gone through in the previous video in the playlist. Then we've got the forward push button. Then in parallel with that forward push button, we have our holding contact. And again, as I'm doing this, it means nothing to you if you don't have the diagram from the previous video in front of you, right? So here's our stop, here's our forward, here's our holding contact. I would bring up your diagram from the previous video so you can keep track of the circuit as I bring it in here. Okay, then we're going to drop in, let's see if I can get over here, and we'll drop in our electrical interlocks. Then we said we're going to have our overload as well, and then finally we're going to have our output. You want to make sure that you don't have any inputs on the other side, on the right side of the output. This is their last thing to go into the rung. Okay, so at that point where we have, let's see, stop, forward holding contact, electrical interlock, and overload, looks good. Okay, so aside from that, we will copy this guy and paste it in. Beautiful. So now we've got identical rungs for the forward and the reverse. And let's see, on our inputs here, we'll bring in our holding contacts. So let's see if these are still the same. Okay, so there's our stop. So we can grab that and bring it up. Come on. So we're bringing it up until we see green. Looks good. Okay, then we've got our forward push button, normally open. We'll drop that here. Then we've got our reverse push button, normally open. Looks good. And then we have to put in our output. So open up our output data table. And I had my forward contactor on output number 2. And I had my reverse contactor on output number 3. And those are the only places we're going to make use of the outputs now. We're going to make, easy now, we're going to create, how do you get back to your main program now? Hang on, just 2 seconds. So we're going to make use of some inputs for our holding contacts and for the overload. So let's see, let's take a look at where we've wired in the forward and the reverse holding contacts. Okay, so off of my I/O table that I have in front of me, I have my input number 5 as my forward holding contact. You know what, I'll just do HT. Okay, and for number 6, I've got that as my reverse holding contact. Beautiful. And let's see, where's my overload? My overload, normally open, is wired up to input number 7. So this is my overload, and we're going to say that's my normally open contact on the overload. Beautiful, looks good. So let's put the overload as the last thing in the rung here. Okay, and then we're going to make use of the forward holding contact, and it's going to go right there. And it's also going to go in line with the opposing contactor. So this will be our electrical interlock for our reverse contactors, so that this guy can't turn on if the forward is already on. And then our reverse holding contact is going to go here, and we're going to make use of that guy numerous times, but just with the opposing instruction. So we're saying that when the reverse is off, allow the forward to turn on. And down here, we're saying that when the reverse has turned on, we're actually looking at that holding contact pulling in and providing us with that signal. So this will give us that rear view mirror effect in that we can turn on the contactor, but we can also see that that actual contact has made and pulled in. So that if it hasn't pulled in, the contactor won't be held in. Beautiful. So that'll provide us with our closed loop now, guys. Okay, so let's check this program to see if there's any issues. So we'll go here to verify the project. Looks good. No errors found. Beautiful. Okay, so let's download this to our PLC now. Looks good. Okay, let's make sure that everything's working first, and then we'll do a picture-in-picture. So stop push button is coming in. Forward is turning on, and when I let go, it actually stays on. Beautiful. And then the reverse is pulling in. When I let go, that holding contact is making and sending that signal in. Beautiful. Okay, let me pause here, and we'll do two separate picture-in-pictures. So first, we'll do a picture-in-picture with the contactor to show you it changing state as the PLC program changes state, and then I'll show you the LEDs on the PLC as well. Alright guys, so let's take a look at the contactors and see them pull in as we change our PLC program. So we've got the stop push button, and you can see that that is changing state on both of the rungs. When I hit the forward push button, you can see that we have logic continuity right across. So remember, it's no longer the path of current, it's the path of logic. Each of these guys, the stop, the reverse, holding contact, and the overload, and the push button, they've all been brought into separate inputs. Input 0, input 1, input 6, and input 7. Okay, we're also looking at the forward holding contact. So we've made use of this normally open contact right here, and we've brought power to it, and off of the bottom there, we're going to, let's see, input number 5. So when this actually pulls in, then you can see that the contactor turns on, right? So let me just turn that off for now. So once we hit that forward push button, then it'll turn on that contactor, and we'll have a signal coming in from the PLC that it's actually turned on. So hitting the forward push button now, and you can see we're going in the forward direction. Okay, once I let that push button go, it stays held in, and this holding contact now has 24 volts that going to the PLC. And this is looking out in the field to make sure that that contactor has actually pulled in. If that contactor was on fire or not working or smoked from something that happened, then we'd be able to see that, as opposed to the open loop where we were just looking at the data table inside the PLC. So right now for this forward holding contact, if I open up my input data table, then you can see here for input number 5 that it is a 1 right now. Okay, so when I hit the stop push button, it will go to a 0, right? So now I have a way to look out in the field to see what's going on. Okay, I'm now going to hit the reverse push button, and we'll see that our holding contact pulls in the reverse as well. So input number 6 should pull in. And again, that's wired here where we have 24 volts to the top. Off of the bottom, we're going to our PLC to physically look to see that that reverse contactor has pulled in. Okay, so that's one way that we're providing with the closed loop. We're actually looking to see whether that contactor has pulled in by monitoring the actual holding contacts on the contactor. Okay, we've also made use of the overload. On the overload on this side here, with 95 and 96, we have our AC in series with our coil. So this conductor goes from A2 through the normally closed and then back to the transformer. On the 97 and 98, the normally open, we have DC. So here we have 24 volts AC, here we have 24 volts DC. And if I trip the overload by opening up this window and then moving that test button to the side, you'll see that this is no longer true, and it will actually turn off or sorry, we have the reverse on, this will no longer be true, and it will turn off my reverse contactor. So we'll trip the overload, which physically stops or interrupts the AC current going to the coil, but also interrupts the logic continuity on my PLC program. So now if I try and hit the forward push button, nothing happens because that overload is not true right now. There's not 24 volts going to that input. And if I hit the reverse, nothing happens as well. On the previous video, when I reset that overload, the contactor turned right back on. But you can see now I can reset the overload, and it's a lot more safer. The machine hasn't turned right back on. It's waiting for me to hit either the forward or the reverse. And just to show you in the forward that if we trip that same overload here, so again with this window you just have to grab it on the side and just push it over just with a control screwdriver. I'm just using a spare piece of wire here, and you can see that that kicks out our coil and stops the forward contactor from turning on. Again, if I reset that overload, then my contactor does not fire back up. Beautiful. All right, guys, let's stop there, and then we'll bring in the PLC, and you'll see the LEDs firing on for each of these guys. All right, so just to finish up, we're looking at the PLC now. This is my stop push button here, so you can see that changing real time on the screen, and you can see that first LED turning on. My forward input is on input number 1, so as I press that push button, then input number 1 is going to fire on. But you're also going to find that input number 5 fires on as well, because that's my holding contact. There we go. You can see both of those LEDs on. When I let go of my forward push button, then number 1 goes out. You can see that number 5 is still pulled in, showing me that I still have the forward contactor pulling in. So this provides me with that closed loop in that I'm actually looking out in the field to see that that coil has actually pulled in. If that coil was on fire, then the holding contact would never pull in because that coil would never be energized. Okay, let's take a look at the overload as well. If I trip the overload, then you'll see that number 7, let's see, number 7 is coming in. Sorry, slip of the tongue there, guys. Number 7 is not coming in because we're examining that there's no voltage there. So as long as there's no voltage coming in from the overload, then that forward contactor will still stay on. So when I trip the overload, then it will send a signal into the PLC. So you'll see that when I trip the overload that the forward contactor goes out, my holding contact is no longer true, so number 5 will go out, and you'll find that number 7 is illuminated, showing us that we are actually in an overload state. There we go. So 5 went out, 7 is now illuminated, showing us that we're in an overload state, and the contactor has pulled out. When I reset that overload, you'll find that number 7 is extinguished. This is then true because we're looking for no voltage, and at that point there is no voltage on input number 7, and allows us to go in the forward direction again. Beautiful. In the reverse direction, when I hit the the reverse push button, input number 2 will be illuminated, and when the reverse contactor pulls in, then number 6 will be illuminated as well. Okay, so you can see that they basically happen at the same time. So there's my reverse push button being pressed. I no longer need it being pressed because this is turned on. My reverse holding contact is pulled in, and I have the signal coming in from that reverse contactor to say that it's on. Again, if I trip the overload, then my number 6 will go out, right? So 6 is the holding contact for the reverse, and 7 will come in. So number 7 will illuminate because that overload has now sent a 24 volt signal in. So here's the overload being tripped. There you go. So you can see that the reverse contactor has pulled out. This is actually physically looking at the reverse contactor. So it is no longer illuminated because we no longer have 24 volts to 6. But on the overload, we now have 24 volts going into that input. We're looking for the presence of no voltage. Right now there is voltage, so that allows us to stop that continuity. So if I try and hit the reverse push button, nothing turns on until I've investigated why that overload actually happened. Then I'm confident to reset the overload. It doesn't turn the contactor on right away. It waits for me to send that signal in to turn it on again. Excellent, guys. So hopefully that explains the closed loop now, and that you're actually using the contacts to provide the closed loop. They're looking out in the field to see that that contactor is actually pulled in. And on the overload state, we're using on the IEC contactor, we're using the normally open to send a signal into the PLC to tell us that we've had an overload that actually occurs. In addition to this, we could also put in some flashing lights to say that an overload has occurred, right? So we could bring in the one of our pilot lights and then have that flashing bit to flash the light to tell us that an overload has happened. Not going to show you guys how that happens because I believe Ted has that as an addition to one of his labs. So we'll leave it for you guys to figure that out. You're combining this guy and the timers, which are going to follow later on in the playlist. Alright guys, thanks very much for your patience. We'll see you in the next video.